Hey, welcome back to Math with Patrick and Quill. Today is May 22nd, and we are solving problem number 142 from the Daily Epsilon calendar. And we need to show why this blue area right here on the triangle, or I guess it is a triangle itself, why the area of this blue triangle is equal to 22 today. And so we're given a little bit of information. We know that this length, and that length are all the same length because of those double tick marks. And I think this 2 times the square root of 55 is talking about the hypotenuse of this right triangle right here. And somehow, from that, we're able to find the area of the blue triangle. So I know when I'm finding the area of a triangle, I need to know its base and its height. I mean, there are other formulas out there that are more complicated, but I think I can solve this with just finding the base and the height. So potentially this is my base, and I need to find some kind of perpendicular height here. Or maybe I could pick this other side as my base, and I could find some kind of perpendicular height. Well, it's kind of hard to spot, but it would kind of be about that tall. But I think the best way to do it is to pick this as the base and this as the height, and they're still perpendicular. This height doesn't really line up well with the whole triangle. Sometimes you'll see it drawn as like a dotted line over here. And ultimately, this length for the height is just going to be another one of those double tick mark sides, because this length here is equal to the height of the triangle there. So if I figure out this length, then I'll be primed and ready to figure out the area of the triangle. In fact, the area of the triangle is going to be, well, 1/2 times base times height. The base here is going to be some unknown length. Let's just call that x. And then the height is going to be the same unknown length. So we can call that the same x. And x times x is just going to be x squared. So hopefully I can somehow use this value here to solve for this missing length. About this small triangle in the corner, since 2 of the sides are equal to each other, I know it's an isosceles triangle, and that means that both of these sides are also, or these angles rather, are also equal to each other. Ultimately, that does mean that both of these are 45 degrees. And the reason why this is helpful is now in the big triangle, I can also tell that there's a 45-degree angle in 2 of the corners here and here. And then finally, that tells me that this side is equal to this side right here. And I can actually fill in some x's for those missing sides, right? This is an x here. This is another x right there. There's an x vertically right here. And then since I have a 45, 45, 90 triangle, it's an isosceles right triangle, I know that this side and this side are going to be equal in length. So if the bottom is x plus x, or 2x, then the right side of this right triangle should also be a 2x. And then finally, getting that length, I can tell that I could finally use the Pythagorean theorem on this right triangle and solve for x. So let's try that out. So the Pythagorean theorem just says a squared plus b squared equals c squared. C is always the hypotenuse, so I'll write 2 times root 55 in for c. Then I don't really have values to plug in for a and b, but I could rewrite it with these variables with x. How about let's just say a is the shorter side? It doesn't really matter which one's which, but let's just say a is the base, so I'll have x squared. And then b can be this other leg, the taller one, and that's going to be 2x squared. So let's just simplify on the left side, collect up our like terms, and then solve for x. Well, x squared can just stay the same. 2x times 2x is 4x squared. And then 2 times root 55 times itself is going to be 4 times 55, right? Because I'm distributing this square to the 2 and also to the root 55. All right. I can combine my like terms on the left. 1x squared and 4x squared make 5x squared. And then how about let's divide both sides by 5 so I can get my x squared by itself. And I guess I'll simplify this part. This 55 divided by 5 can be 11. And then so 4 times 11 is 44. So I don't actually need to solve for x, because what I can do here, now that I have an expression for x squared, I can just plug in 44 right here, and then I can really quickly solve for the area of the triangle because I already have this equation set up. Well, the area of the triangle, that blue area that we're trying to find, is just going to be half of 44, which is the same as 22, and that is today's date. Cool. So some Pythagorean theorem, knowing some stuff about isosceles triangles, that let us figure out that the answer today indeed matches the date. Okay, I'm all done. I hope you enjoyed solving this with me, and I'll catch you tomorrow. Okay, bye-bye.